At the atom in a bit more detail now. An atom is composed of a nucleus and principal quantum shells, or more simply, the shells. We've talked about the nucleus, that it contains protons and and neutrons in the previous videos. Now we are going to look at the shells in a bit more detail. Shells are also called energy levels. They are also called principal quantum shells. They are also referred to as just shells, and this is where the electrons are present. The shells contain electrons. Okay. Each principal quantum shell contains smaller regions called the subshells. There are four subshells, namely S, P, D, and F subshells. Each subshell contains smaller regions called the orbitals. The P subshell contains three orbitals, namely Px, Py, and Pz, whereas the D subshell contains five orbitals, namely dxy, dyz, dxz, dx squared minus y squared, and dz squared. The probability of finding an electron is maximum in an orbital, which is approximately 95%. So an orbital is a region. If we are asked to define an orbital, it's a region where the probability of finding an electron is maximum and approximately 95%. Orbitals contain most probably the electrons. Okay, now let's go forward. The principal quantum shell around the nucleus of an atom. This is an atom. The black dot represents the nucleus and the red represents the principal quantum shells. Each principal quantum shell is symbolized by N, the alphabet N. The first quantum shell is given a value of N being equal to 1. The second one is given a value of N equals to 2, and so on. As we increase the number of shells, the value of N increases. The more we go away from the nucleus, the greater will be the energy of the shell. So basically, the value of N also represents the energy of the electrons in that shell. So the further apart the shell is from the nucleus, the greater will be the energy of the electrons present in that shell. So the greater the value of N, the greater is the energy of that shell. Now let's look at a very important formula. The maximum number of electrons that are present in a shell is given by the 2n squared, where n represents the principal quantum shell, the principal quantum shell number. The first shell, the first shell has a value of n being equal to 1. So just plug it into this formula and a maximum of 2 electrons are present in the first shell, and that can be accommodated. More than 2 electrons cannot be accommodated in the first shell. They have to go to the next shell. Then the second shell, it contains 2 times 2 squared equals 8. So a total of a maximum of 8 electrons can be accommodated in the second shell. A maximum of 18 electrons can be accommodated in the third shell, and so on. So as the value of n increases, the number of electrons that are present in that shell that can be accommodated in that shell also increases. Okay, now let's look at the next formula, the maximum number of orbitals. The orbitals, which we've just discussed above over here, the region of where the probability of finding an electron is greatest. Now, how to find the number of orbitals present in a shell? It's given by the value of, by the formula n squared. So the first shell contains, just plug in the value of n as 1, and contains only one orbital. The second shell contains 2 squared is 4 orbitals. The third shell would contain 9 orbitals, 3 squared being 9 orbitals, and so on. These two formulas are very important, so you guys must remember them. Okay, let's move forward to the subshells now. Okay, subshells. The S subshell. This is something that you guys need to learn. This is just some learning stuff. I'll go over it. The S subshell contains only one orbital. And yeah, one more thing. Each orbital, each orbital can at a time have a maximum of two electrons only, maximum of two electrons only. So an orbital can contain a maximum of two electrons only. The first subshell contains only one orbital. So one orbital would mean that the number of electrons present in that shell, in sorry, not the shell, the subshell, the first subshell, the S subshell, contains only one orbital, and so the number of electrons present in this orbital is two because each orbital contains two electrons only. Okay, then the next subshell P contains three orbitals which we've discussed earlier. Their names are Px, Py, and Pz. I've discussed them above as well. Px, Py, and Pz. Each of the p orbitals will contain two electrons, so two here, two there, and two here. 2 plus 2 plus 2 would give us 6 electrons. So the number of electrons present in the p subshell is 6. The d subshell contains 5 orbitals, namely dxy, dyz, dxz, dx squared minus y squared, and dz squared. Each orbital contains 2 electrons, so a total of 10 electrons can be accommodated in the d subshell, and each orbital having 2, because each orbital has 2 electrons. The f subshell has 7 orbitals, so the maximum electrons that can be present in the F subshell is 14. Okay, now let's look at the shapes of S and P orbitals because they are in our syllabus. The S subshell is spherical in shape. So this is somewhat its structure. It's spherical in shape. The P subshell is dumbbell in shape. Dumbbell is basically a structure which contains two lobes like this. The lobes are approximately equal. Okay, the px orbital of this subshell, the px orbital of the p subshell is the dumbbell in shape, and it's called px because it's parallel to the x-axis. The py orbital is also dumbbell in shape, and it's py, so that means it's gonna be parallel to the y-axis. And the pz orbital of the p subshell is also dumbbell in shape, but it's pz. So this means that it's parallel to the z-axis. And finally, let's look at the relative energies of each of the subshells. The S subshell has the lowest energy, followed by the P subshell, which has a greater energy, which has greater energy compared to the S subshell, then followed by D, and F has the greatest energy.